Okay, in this video lesson, we're going to begin talking about how to solve a quadratic equation. So again, anytime we are trying to solve any sort of equation, our goal is to try and figure out the value of x, or whatever my variable might be, to figure out what value is going to make the equation true. Now, when we solve a quadratic equation, what we are going to do is we're going to have our quadratic equation set equal to a number. And more than likely, you're going to see a quadratic equation set equal to 0. So you're going to see, our quadratic equation, the ax squared is what makes it quadratic, plus bx plus c is going to equal 0. And our goal when trying to solve this is we're going to try and figure out what value of x is going to equal 0. What's going to make these types of equations a little bit more difficult is, let's say I were to give you something like 2x squared plus 3x minus 4 equals 0, is that when I try to solve this, let's say that I add 4 to the other side, that as I try and solve this, there is no way for me to combine these terms. Because they both have an x, but because this has an x squared, they are not considered like terms. So if we go back to the idea of things being like terms, that they must have the same variable, which is something we looked at in prior equations that we tried to solve, but they must also have the same exponent. That's kind of what we talked about in terms of solving exponential equations, but in this case we cannot combine the x squared and the 3x because the x squared has a exponent of 2 and the 3x only has an exponent of 1, so those are not considered like terms. So our goal again is to still find the solutions. The only difference again is that we're going to have to solve these, I guess, a little bit differently. So when we solve a quadratic equation, again, what you're going to see is all these quadratic equations going to be set equal to 0. So when we find a solution, we're going to find what are called zeros or roots, and we'll talk about roots today. But when we talk about zeros, we're going to try and find the value of x that's going to make the equation equal to 0. So we're always going to make sure that our quadratic equation is equal to 0 before we go ahead and solve it. All right, now today what we're going to do is we're going to learn how to solve quadratic equations using what's called a square root. So square root is a mathematical operation. A square root is represented by this symbol right here called a radical. So you might have seen this before. Like, let's say I have a number 25. If I'm going to take the square root of that number, I'm going to put a radical over the top. And what a radical does, or what a square root does, is it's going to think about the inverse of squaring a number. So quadratics take x and we square it. That's what makes something quadratic. So the inverse of squaring something, which means the opposite, is going to be to square root that thing. So when we look at a number like, let's say 25, and I think about the square root of 25, what I'm really looking at is what number squared would give me 25. And when I'm trying to solve something by using a square root, I'm just simply doing the inverse of squaring something. I'm trying to figure out that number when squared would give me 25. Okay, so anytime we want to find the square root, that's the process that we're going to try and think about. Now, as we go through and solve square roots, you are going to get some nice numbers. Like, for example, the square root of 25 is 5. 5 squared would give me 25, so the square root of this number is just simply 5. But sometimes as we do this, we're going to take the square root of numbers that cannot be solved that way, or cannot be, I should say, simplified that way. So let's say I took the square root of 20. What I'm asking for is what number squared would give me 20. But if I think of this, okay, like 1 squared would give me 1, 2 squared would give me 4, 3 squared would give me 9, 4 squared would give me 16, 5 squared would give me 25, and so on and so on. But notice here that there is no number 20 in my list here. This is a list of what's called perfect squares. I don't see the number 20, which means when I take the square root of 20, there's not a whole number that I would ever get. What I'm going to get, though, is I'm going to get a decimal of something between 4 and 5. If 4 squared is 16 and 5 squared is 25, the number 20 is somewhere in the middle. So that means I'm going to get a decimal maybe around 4.4 or something. All right? So sometimes when we deal with numbers that cannot be square rooted into a nice whole number, numbers that are not a perfect square, we're going to have to talk about those numbers in simplest radical form. So we're going to look at first these idea of square rooting numbers and also looking at the idea of simplest radical form. Now, when we are trying to solve this, just to kind of bring this back to the idea of graphing, again, we are looking for what's called a solution or a zero, and by doing that, we're taking square roots. All these things are going to be the same thing. But what we're doing is we're trying to figure out what value of x would make my equation equal to 0. If we relate this back to graphing, okay, the value of x that would make my equation equal to 0 would just simply be the values of x when y is 0. So on a graph, these are going to be the points where my graph crosses the x-axis. For example, this would be a point of 1, 0. This would be a point of negative 3, 0. So those are two values of x where y equals 0. And this brings up another point, that when we solve quadratic equations, we're not just going to get one solution, but with this one quadratic equation, I am technically getting two solutions. I am being told that x is equal to negative 3 and x is equal to 1. So instead of one solution, I actually get two. So we're going to discuss how we get these potential solutions. Because when we graph a quadratic, it is possible for us to get two solutions. It is possible for us to get one solution. It is also possible for us to get no solution. All right, so let's talk first about the idea of square rooting something. So today we're going to solve quadratics through the use of square rooting. So when we square root of a number, like let's say we have the square root of 100, what we are trying to think about is whatever number is inside the radical symbol. So again, this symbol is not the long division symbol, but this is the radical symbol that we use to represent a square root. Essentially what we're asking is what number squared would equal 100. Again, squaring a number means what number times itself would give me 100. Now thinking through this, you might know that 10 times 10 would give me 100. So one of my solutions is going to be 10, because 10 squared is going to equal 100. Now there is one thing that I just talked about, is that when we solve these quadratic equations, it is a possibility to get two answers. The question is, where does that second answer come from? And it actually comes from the idea of squaring something. When you square something, it's a number multiplied by itself. Now something that we learned about a long time ago, kind of with basic arithmetic in terms of multiplication, is that when you multiply two positive numbers, you get obviously a positive. However, you also learned that if you multiply two negatives together, so negative 10 times negative 10, that's also going to give you 100. So not only is positive 10 going to be an answer, but negative 10 is something that I also have to consider. So here, when taking the square root of 100, I don't just get 10, but I have to think about positive 10 and negative 10. So because I have to think about that, here's how we're going to write it. When we take the square root of 100, we're not just going to write 10, but we want to think of positive and negative 10. So you will hear me say, right here, this symbol means plus or minus, that we are considering both the positive number and the negative number of whatever that square root would be. So now if I take the square root of 64, the square root of 64 by itself is going to be 8. But because I want to consider both options, it's going to be positive or negative 8. Okay? And in this last one, I have the square root of negative 49. So notice the difference here is that I have a negative number on the inside. So negative number means I want to know what number squared would give me negative 49, which means, again, what number times itself would give me negative 49. So right off the bat, you might think 7, right? 7 and 7 would give me negative 49. So 7 and 7, well, when you think about this, if they're both positive, it's not going to give you a negative number, but 7 and 7 would give you positive 49. So then you might think, okay, what about negative 7? So if I did negative 7 times negative 7, well, I just talked about two negatives would also give you a positive. The only way that you're going to get negative 49 is if you multiply positive 7 and negative 7. Okay? Now, positive 7 and negative 7 are not the same number. If you think of a number line, 0 in the middle, positive 7 would be all the way over here, and negative 7 is all the way over here. Those are two completely different numbers. So what this means is that I cannot take the square root of a negative number. It is impossible for me to multiply the same number together and get a negative. So this tells me that if I have to take the square root of a negative, that right away there's going to be no solution. Okay. So we could have potentially two answers. It is possible to talk about, and I'll talk about it through problems to get one answer, and it is possible if I'm ever taking the square root of a negative to get no answer. All right, now I'm going to go through some examples of what happens when you don't have what's called a perfect square. So for example, if I were to take the square root of 108, if you have a calculator and you type that into a calculator, your calculator is going to give you something different. Okay, it's either going to tell you two things. One, it's going to give you a decimal like I talked about before. So as a decimal, this would be around 10.39, and then it kind of goes on and on. All right, or your calculator is going to give you something weird looking, 6 square root of 3, and what I'm going to say 6 radical 3. So this right here is what happens when I have a number that is not what's called a perfect square. Perfect squares are numbers shown over here. So 1, 4, 9, 16, 25, all the way up to 100. These numbers are called perfect squares because when I take the square root of those numbers, I'm going to get a whole number. And I'm going to get a whole number because each of these whole numbers, when you square them, is going to give me the number that's inside the radical. So notice, if I were to continue this list here, 108, well, the next number that I would square is 11. 11 squared would give me 121, which is not on my list of perfect squares. So when I take the square root of a number that's not a perfect square, I'm either going to get a decimal or I'm going to get what's called simplest radical form. Okay? So what I'm going to do here is I'm just going to talk about where you get simplest radical form, just so you can understand in your calculator what it looks like, or where it comes from, I should say. So the number 108 is, again, not a perfect square, but here's how we get simplest radical form. I'm going to take 108 and I'm going to try and break it down into factors, and one of which is going to be a perfect square. Now when I say the word factors, that means two numbers that multiply together to give me 108. Since there is not the same number, right, I can't find like 2 times 2 to give me 108. So what I'm going to do is I'm just going to find two numbers. But one of these two numbers is going to be a perfect square. So let's just say it's the first number here. So this first number is going to be a perfect square, which again is going to be a number that when you square root it would give you a whole number. So when I say a perfect square, I am referring to these numbers on this list, okay? 1 all the way up to 100. Now when I talk about factors, again, I'm going to think about which of these perfect squares when multiplied by another number would give me 108. Now, just to kind of give this away, for 108, it is 36 times 3. So what I'm going to do is I'm going to keep that radical symbol, but I'm going to break down 108 into two factors of 36 times 3. Now, there's a property of square roots that if I'm taking the square root of two numbers being multiplied together, what I can do is split this up. I can do the square root of 36 times the square root of 3. Now, when I take the square root of 36... the square root of 36, well, that's a perfect square. The square root of 36 is 6. So when simplified, the square root of 36 is going to become 6. And then radical 3, the square root of 3 is not on this list. So what I'm going to do is I'm going to leave it as 6 square root of 3. So in the end, this would be considered simplest radical form. And notice that matches what I would get if I plug that into a calculator. The only thing I would add on to this is based on what we talked about in the previous slide. When I take the square root of things, I'm going to throw on here the plus or the minus in front of that. So it's plus or minus 6 radical 3, which is the same thing as saying 10.39 ... So it's a number that's a little bit bigger than 10. All right, showing a couple more examples here. So I'm going to start off with the square root of 45. So my goal again is figure out which of these perfect squares goes into 45. Recognizing right away, 45, you might know, is 9 times 5. Why I'm picking that one is because 9 is a perfect square. So when I do the square root of 9 and the square root of 5, what's going to end up happening is this will simplify down to 3 and then radical 5. And then I'm just going to throw the plus or minus in front of it to show we're looking at the plus or minus of that number. 125, you might be thinking, okay, 25 times 5. So again, if I take the square root of all that and then separate it out, square root of 25 times the square root of 5, square root of 25 is 5. And then that radical 5 cannot be square rooted because it's not a perfect square. And then again, throw the plus or minus on top of it. So again, what I'm looking for in each of these problems are numbers like 9 and 25, numbers that are called perfect squares that go into that number. All right, a little bit sassy here, but I want you to try these last two examples. 343 and 75. Give these two a shot when you're taking the square root of them. All right, so I split up the first one into 49 and 7. Square root of 49 is 7, and that radical 7 cannot be simplified because it's not a perfect square. So simplest radical form would be plus or minus 7 radical 7. And here I would get 5 radical 3, breaking down 75 into 25 and 3. Now again, this is something you're going to see as we go about solving, that if we ever take the square root of a number that's not a perfect square, sometimes you're going to see this perfect radical form shown. All right, so now let's actually get into solving using these square roots. So when I solve using a square root, again, what we're going to do is kind of go back to old school solving equations. We are going to use inverse operations, okay? So just like solving a normal equation, the first thing I'm going to do, number one, is I'm going to look to simplify things. So can I combine like terms? Can I distribute anything? And once I'm done simplifying, then I'm going to do those inverse operations. Inverse operations, again, means do the opposite. So where I see addition, we subtract. Where I see multiplication, we divide. And then lastly, where I see squaring, we are going to square root, okay? So squaring and square root are going to be the opposites of each other now. So in this first example, I have 3x squared minus 27. So notice you have the x squared. So let's solve this like we would a normal equation. Let's start off first by doing simplification. Now notice here, everything's simplified. These are two things that I cannot combine. There's nothing to distribute. So once I do that, then I'm going to do my inverse operation. So I'm going to add here 27 to both sides. So I'd get 3x squared equals 27. I have the 3 in front, so I'm going to divide by 3. And I'm going to get x squared equals 9. Now what I'm left with is I'm left with x squared. So my goal when doing inverse operations is I want to try in the end to get, I'm going to try and get x squared equals a number. Because once I get to this point, then my goal would be to do the inverse of squaring, which is to square root. What that does, x squared, when you square root that, these are going to cancel out, just like we would 3 divided by 3 or adding 27. Those cancel to just give me x. Then I take the square root of 9. The square root is an operation, so it's asking what number times itself would give me 9. In this case, it's 3. And then I got to remember, because we want to consider both positive 3 and negative 3, I'm going to tag on the plus or minus 3 at the end. So in the end, I get 3 and negative 3 as my two answers. All right, next one. Again, same thing. Here I'm going to add 10 to both sides. That's going to cancel, so I'll get x squared equals, and then negative 10 and positive 10 would give me 0. And once I get to this point, I'm going to take the square root of both sides. That's going to cause that to cancel, and I'm going to get x equals, and this brings up a good point. We have the number 0. A lot of times when people say, oh, we got the square root of 0, that means no solution. But in this case, what I want you to think about is that 0 is a number. For example, at home, I have no cats. I have 0 cats. It is an actual number. And 0 is a perfect square, because 0 squared, 0 times itself, 0 times 0, gives me 0. So if I ever have to take the square root of 0, boom, I get 0. Now my question for you, does it make sense to say plus or minus 0? And in this case, if you think about it, it does not. 0 is not positive, 0 is not negative, 0 is nothing. Okay, so in that case, this would be the situation in which I would have one solution. X equals 0 is my single answer, nothing else. All right, now let's take on an extra little bit more sass again here. So I'll do one more example here, negative 5x squared plus 11. So first thing I'm going to do is subtract 11 from both sides. I would then get negative 5x squared. Here, 16 minus 11 is going to give me 5. I'm going to then divide both sides, by negative 5. That's going to cancel, and I'd get x squared equals negative 1. Then I take the square root of both sides. So I'll take the square root of x squared to get that to cancel, and the square root of negative 1. And when I take the square root of negative 1, whoa, wait a second. Square root of a negative number? That's not possible. So in this case, there's going to be no solution. So anytime I ever have to take the square root of a negative, that means no solution. And even if you plug that into your calculator, it's going to give you an error symbol because you cannot throw a negative underneath the square root. All right, let's have you guys try number D on your own. Get it, number D. Try that example on your own. Solve that for x by using square roots. All right, now solving this one, I added 13 first. Divided by 4, I got 7. And then I took the square root again to cancel out that square. And I'm taking the square root of 7. And here I wrote it. Because 7 is not a perfect square, I wrote this in simplest radical form. Now, 7 by itself can't be broken down in anything. So I write this as plus or minus radical 7. Now, again, plus or minus radical 7, I do that because it's not simplest radical form. As a decimal, you would get about 2.64, and then it goes on and on and on. So again, we're just taking that would be a run-on decimal, and we are writing that as a radical because it's just a very simplified way to do it. All right, here's our last two examples. I'm going to throw a little bit of sass here. So in this case, notice we have parentheses. Ooh-wee. So think of this as like being in vertex form. I have 2x plus 1 inside parentheses, and notice I have the square on the outside. So when I have something like this where I have parentheses but the square is on the outside, what that means is I have, again, some number. What I'm trying to think about is some number squared is going to give me 36. Whatever that number is on the inside has to equal 36. So here's what we talked about. I'm going to set this one up a little bit differently, but a number times itself has got to be equal to 36. So we came up with two things, that we need to have 6 or negative 6, because both of these numbers squared would give me 36. So what that means is whatever's inside the parentheses, 2x plus 1 has to equal 6, or 2x plus 1 needs to equal negative 6. So I'm still going to get two answers, but notice what happens here. If I subtract 1 to both here, and I'll get 2x equals 5, and divide it out, I'm going to get 2.5. Okay, if I solve this one by subtracting 1, I'll get 2x equals negative 7. Divide by 2 again, and I'll get x equals negative 3.5. Not the prettiest of numbers, not the worst, but notice I'm still getting two answers. The only thing, though, is that these answers are not plus or minus the same number. It's not plus or minus 8 or plus or minus 2, but I get positive 2.5 and negative 3.5. So my two answers are a little bit different. And if we think back to like a graph of a parabola, what this is showing here is that my graph is not centered around the origin. It's going to be centered around somewhere else, such that I would have an answer here and an answer here. So kind of shifted a little bit. So anytime you see that parentheses around and you see the x on the inside with some extra sass in there, that means we're going to have to think about this one a little bit differently. Now, there's another way to solve this right off the bat, is I do have my, again, x minus 1 squared equals 25. So I can think about it here that, okay, it's got to be 5 or negative 5. But just to show you how else I can do this, I can take the square root right away instead of saving it for the end. That's going to get it to cancel, but if I square root 25, here's what I have to remember. X minus 1 is going to equal plus or minus 5. When you take the square root of a number, it's always plus or minus. So what this means is this. X minus 1 can equal 5, and x minus 1 can equal negative 5. Just kind of doing it the same way, but this one, I guess, just requires a little bit less thinking. But then I'm going to add 1 to both sides for each of these, so I get x equals 6 here, add 1 to both sides here, and I'm going to get x equals negative 4. So again, I still get two answers, just notice they're not plus or minus the same number. So here we learned about solving by using square roots and being able to express our answers both as positive or negative of some number and in simplest radical form. So if you've got any questions, jot those things down. Otherwise, good luck on the practice.